Okay, so can you calculate degree of freedom for this first reaction CaCO3? It is in equilibrium with CaO and CO2. Can you try? Two. You are saying two for first condition for reaction one, right? So can you tell me why? Like, can you tell me number of phases? Total number of phases for this reaction. C minus P plus 2. Yes, you can apply, but here issue is P is 3 phase. One second. Three phase where two is solid, two solid phase plus one gas phase. So total phase 3. And number of species here there are three number of species CaCO3, CaO and CO2, right? And we know C equal to N minus. Can you tell me what is C minus P plus 2? What is C? Minus T and F equal to, yes, F equal to C minus P plus 2. We know this equation. So C from this equation, number of species is 3 minus R is number of independent reaction. So it is at equilibrium, so number of independent reaction will be 1 minus S is stoichiometric constant, or this is special constant, T is special constant. So minus 0 minus 0 both are 0. So 3 minus 1 2. So if we put here 2 minus P, it is 2 plus 1 3 plus 2, so it will be 1. So degree of freedom will be 1. Either temperature or pressure must be specified for this equilibrium reaction. Are you getting? Okay. Can you solve by similar way? Can you solve this reaction too? Let me write. This is gaseous form. This is also in gas form. Gaseous form. How many phases are present in equilibrium? Okay. Yes. Yeah. Are you telling about F value or three phases? How three phases? It is a single phase. All are gases, right? Here, these are two solid, solid plus solid, solid CaCO3 and one solid is CaO. So at equilibrium, it is in solid, so we cannot mix each other. So there are two phases plus one. One is in gaseous form. So total number of phases will be 3. 2 plus 1. But here, if we calculate phases, all are in gaseous state, so we can mix. So number of phases will be 1 at equilibrium. Are you getting? We cannot identify which one is H2, which one is I2, and which one HI value, HI, right? So, here we can calculate C value. It is species. Species is N value is 3. 3 minus reaction. There is only one equilibrium reaction. minus 0 minus 0, so it will be 3 minus 1 2. So degree of freedom will be f equal to 2 minus p value is 1 plus 2, so 3. So total degree of freedom will be 3 for this. Okay. Can you calculate degree of freedom when ice, water, and water vapor coexist in equilibrium? Similar way, yeah, we can calculate. But here catch is, here R value will be 0. There is no reaction. How many phases are? Can you tell? P value. What is P value? Yes. And C value? N minus R minus S minus T. Species is 1 only. N value is 1. R, S, and T all are 0. So C value will be 1. So if we calculate F value, it is minus C minus P 3 plus 2. That means it will be 0 degree of freedom for ice, water, vapor. If coexist in equilibrium, then degree of freedom will be 0. Is it okay? Oh. So it is important, means you can say forget it is important. It was asked in GATE 2018 and 19 also. You can check. Can you try for this question? Here total time for certification of a cubic casting of dimension 5 into 5 into 5 centimeter cube is 1.6 minute. So what is given? Time is given, it is 1.6 minute, and volume of cube is a cube. So we can write 5 cube centimeter cube. What will be the surface area? 6 years. For surface area for cube, it will be 6a square. So simply we can write 6 into 5 square centimeter square. This is for cube. A cylindrical riser with diameter to height ratio 0.5 means for cylinder diameter to height ratio is given 0.5, and the time for solidification of riser is 3.2 minutes. This was for cube, this was for cylinder. So from here we can write what will be the surface area for cylinder? Surface area. Suppose this is cylinder. So what will be the surface area? This area and this area, right? Yes. 2 pi r into h, where h is height and r is radius, plus pi r square. This surface, top surface and bottom surface. So 2 into pi r square. and we also know this ratio d by h. So here we can write h equal to 2d or 4r. So 8 pi r square plus 2 pi r square, which will be 10 pi r square. What will be the volume of cylinder? Yes, pi r square h. So we are converting h into r. We already know this relation, it is given in equation. So we can write pi 4 pi r cube. And from Chauvin's rule, h value, yeah, it will be this one. Yes, it is right. So from Chauvin's rule, we know surface time, it is proportional to v by a square of n. But in this question, it is given 2, n value 2. So simply we'll take ratio for q and for riser. It is given 1.6 by 3.2. So it will be 1.2 v 5q, this one, by 6 into 5 square into this one, 10 pi r square by 4 pi r cube. So it will be cancelled out, into 100 by, if you simplify, you simply get the answer, and we already know it is 1 by 2. So r value you will get, how much r value you are getting? 2.94. So h value from there you can calculate, it is 4r, so 11.78 centimeter. Yes, 2.94. Yes. So is it okay for you? Can you try for this one? Everything is given, like maximum it is 200 megapascal and minimum is 0, and the component has initial crack length. AI value is given 1 mm. We can write 1 into 10 to the power minus 3 meter. Propagation is governed by this equation, where crack length A is in meter, n is number of cycles, and delta K is in megapascal, the length of the crack after 1 million of cycle. So just we have to integrate from 0 to 1 million cycle. We will find the final crack length. And we know 10 to the power minus 10. भैया अभी, so delta K we know it is function of A. So we can write sigma pi A. So it is given delta K Q, and sigma value it is given 200 maximum value. We will take maximum value because when sigma is in positive, means if you plot that this curve SN curve, then if sigma max will be the maximum, means 200 megapascal stress, then the crack will grow. If it is 0, then crack will not grow. So we will ignore this sigma mean. So it will be 200 q pi to the power 3 by 2 into a to the power 3 by 2. So can you put all value and calculate? You just integrate n value from 0 to 10 to the power 6, and a value, we know ai value means initial crack length, it is given 1 into 10 to the power minus 3, and we have to calculate the final one, af value. You try. 10 to the power minus 12 dn 0 to 10 to the power 6 dA by a 3 by 2 ai to af 1 by 200 to the power 3 into pi 3 by 2. So we have all we have written all this integration. If we simplify it, we will get 10 to the power minus 12, this 203 into pi 3 by 2 into 10 to the power 6. If we integrate dn value from 0 to 10 to the power 6, we will get 10 to the power 6. And what would be the integration of 1 by a to the power 3 by 2? Can you tell? It varies from ai to a. What will be this value? We can write a minus 3 by 2 dA. So it will be a minus 3 by 2 plus 1 divided by minus 3 by 2 plus 1, and it varies from ai to a. So this is constant, so it will come out, this will be minus 2. So we can write minus 2 1 by, and this is, we can write a to the power minus 1 by 2. So this is square root of a. Are you getting? Comments till now, it is okay for you, right? So you can take a value 1 by af value, and this value we will get how much? Minus 22.27 plus 31.62. So af value you will get 9.0.0114 meter. This is your final answer. You can ask. Here only integration is important, means just you put all value, you will get from 0 to 1 million cycle, and you know this a value, right? Initial crack length it is given, and we have to calculate the final one. Yes, 0.011. So what will be the electro standard cell potential for this reaction? 1.1 volt. How did you solve? It is right. How did you solve? See, this reaction we can write uh, Cu 2 plus 2 Cu, means we have 2 electron. this is half reaction, we can say. And likewise for zinc we can write zinc, it is forming zinc 2 plus plus 2 electron. Second, so here from Cu 2 plus to Cu, E naught value is given, it is 0.337 bar. And for zinc 2 plus to zinc, it is given minus 0.763. But in this half reaction, this is zinc to zinc 2 plus. So E naught value will be minus 0.763. So it will be plus 0.763. So if we add, we will get this reaction. Copper plus zinc 2 plus. So if we add this one, we will get for this whole reaction. So 0.337 plus 0.763, which will be 1.1. Okay. Okay. Yes. Is it okay? Here we have to calculate the ratio of resilience to toughness, and yield stress is given and fracture strain is given. So how will we calculate? Can you tell? And Young modulus value is also given. What is resilience? It is perfectly elastic and plastic material. So this is perfectly elastic, and after that it behaves perfectly plastic, right? Suppose it gets fractured here, where strain is 0.45 and yield stress is given 450 megapascal. So what will be the resilience? Suppose I am writing 0, O, A, B, C, D. We tell what is the resilience. Ramesh, if you try in this way, you can solve any problem. Like, don't like add simply. If you write in half reaction for this equation, you can solve any problem. There will not be an issue. So here you tell me what is the resilience. Area, you can tell area also. 450 megapascal. How did you calculate? We have not calculated uh, strain rate. Actually, you have calculated from elastic modulus, right? So what is the area? OAB, right? This area. And what is the this modulus? Sorry, toughness. You know, ratio of resilience. Resilience ratio means OAB, right triangle. OAB by this whole area, right triangle. OAB plus ABCD, area of ABCD. So we know this elastic modulus is given 4.5 gigapascal. So from here you can calculate strain. Directly you can solve it by just eliminating this strain. But here if we calculate strain, it will be 450 megapascal into 4.5 into 10 to the power 3. That means 100 into 10 to the power minus 3. So we can add 0.1. So this is 0.1. So what would be the area? 1 by 2 into this length, 0.1 into this 450. Likewise, similarly for this toughness calculation, it will be 1 by 2 into 0.1 into 450 plus what is the area of rectangle ABCD, this length, it will be 0.35. I have subtracted 0.1 into this one because it is behaving completely plastic after a yield point, therefore it will be 450. So 450 it will be cancelled out, and the remaining will be 0.05 by 0.4. So what will be the answer? 0.125. This is our final answer. Are you getting, Kamesh? Okay. So can you solve this one? Predominance area diagram, right? For this BC, what will be the slope? We have to find out the slope of this BC. See here, it is log P SO2, partial pressure of SO2, and log PO2. It is given. So simply what you do, you write a equation NIO and NiSO4, and you find K value from there, and we know this from the reaction. If you put, you will get some equation y equal to mx plus c, and this m value will be the slope. We have to find out this one. So what will be the slope? Are you writing equation? Can you tell me what will be the equation? What will be the reaction here? Hello? See, it is asking for BC only, right? So one side we can write NiO, other side we can write NiSO4, and just you balance by adding O2 and SO2. NiO plus SO2, NiO plus SO2 equal to O2 plus NiSO4. So Ni is balanced, sulfur is also balanced, but oxygen 3 and 4 2, it is not balanced. Oxygen, you see the oxygen both sides, it will never balance. See, this is one Ni, one sulfur, and this is one Ni, one sulfur. So if you increase the amount, oxygen content will increase 4 times. So you write this one SO2 plus O2. Then if you try, you can balance now. You are right, this equation right, but if you try to misbalance, it is difficult. So better you write this oxygen this side, because that side oxygen content is very high, 4 times. So if you just increase 2 Ni, then it will be, we have to multiply here 2 also, 2 NiSO4, so oxygen content will be 8. Are you getting? So just write like this one. Did you get now why I am not choosing this reaction? So find out now K value for this one. Activity of NiSO divided by activity of NiO into partial pressure of SO2, it is in gas, into partial pressure of O2. Sorry, I have not balanced. So Ni is 1, okay, sulfur is 1, oxygen is 4, so just 1 by 2. So this is 1 by 2. Okay, you are right. So activity is 1, suppose it is impure form 1. So simply we will take ln both side. It is log, see log, so we will take log. Log k will be equal to log p SO2 minus log p SO2 minus 1 by 2 log PO2. So this is y-axis means this is y. So log PSO2 will be equal to minus 1 by 2 log PO2 plus log K. This is minus log K. So slope will be y equal to mx plus c. So this m means this is slope up. Slope will be m equal to minus 1 by 2. 0 0.5 minus 0 0.5, it is our answer. So did you get this? Is it okay? Okay, I am doing one question here. If you search predominance area diagram for this NiO system, NiO and sulfur, you will get this type of curve. This is also a slope type. This area is called NiSO4. Means it is stable. This is NiS. This is NiO. This is nickel. And this is Ni3S2. This is log PO2. This is log PSO2. What you try now? You try to find all slope. This slope, well, suppose this slope. Then try to find out this slope. After that, you try this one. You can try this one also. This slope. Why this is means? Uh, what should I say? It is parallel to y-axis. Can you tell? Can you calculate and show me why it is parallel? NiSO4. So here O2, 2 oxygen. Why it is parallel? You try to find out all slopes. You just search predominance area diagram for this nickel, sulfur and oxygen. You will find this diagram. Why it is parallel to log PSO2? This one is also parallel, right? You can write Ni plus half O2. This is for this one. This is second one. This is first one. This is second one. This is first one. Why it is parallel? SO2 term is not there. Yes. So if you find out, you will not get this SO2 term. Simply you will get this one. So it does not depend on this axis. That's why it is parallel. You are right. So you try to find out also, right? Is it okay? So we are going to next question. Okay, you just told me that one thing, that it does not, SO2 term is not there. So can you find this one for bias diagram? It is the similar question, means not similar. means based on same concept you can tell. That's why I have given this one. From here you see, if you search for bias diagram, you will find that it is actually potential versus pH diagram. Earlier it was phosphorus, PSO2 and PO2, partial pressure of sulfur dioxide and partial pressure of oxygen. Natural log that was and in log term also there. So can you tell me what will be the correct diagram? See, and from this equation you can tell this is AlO2 minus directly. Here, if you observe, electron does not, there is no electron. It will consider 3 plus 4 plus 3 plus electron, and product side you will get 4 plus ion minus 1. So 3 plus right side, and left side also 3 plus. So there is no involvement of electron. So this potential value will be constant. So what will be the value now? pH value, it varies only pH value, H plus value, from H2O to H plus. It does not liberate any electron, this reaction. Option C. That's why option C will be the right. You can also search this pH diagram for iron and iron oxide. You check. I don't know whether it is. See, this is Fe 3 plus. This is Fe OS thrice. This is Fe 2 plus 2. This is Fe. This is pH value, and this is potential. So here, if we go from Fe plus 2 to Fe 3 plus 1 electron, okay, and from Fe to Fe2 plus Fe plus 2 to 2 electron. So we will see that there is no H plus ion in both. That's why it is this one. Are you getting? It liberate only electron. You try this one. Here we have to find volumetric strain. So strain is given, means Poisson ratio is given and strain is given. So what will be the volumetric strain when a rod is elastically deformed by in its axial stress? We know this volumetric strain, it will equal to sigma x plus sigma y plus sigma z. Sigma not, this is epsilon in x direction, y direction, z direction, and we it is given epsilon x value is given 0.02. So what will be the value strain in y direction? Minus gamma epsilon naught x. Yes, we can use that formula if we know, like this one minus gamma epsilon x minus gamma epsilon x. So 1 minus 2 gamma. We can write if we remember the equation, this that formula, then we can, it is easier. But even if we do not know, from this one we can calculate one by one, and just we simply add, we will get this volumetric strain. Is it okay? So it is 0.02, 1 minus 2 gamma, 2 into Poisson ratio, it is given 0.3. This is 0.00, this is volumetric strain. You try for this one. Here critical edge length of a cube shaped nucleus we have to find out, and for homogeneous nucleation of solid and liquid of pure metal, surface energy and change in volume free energy is given. So how will you calculate? Okay, 2.5 nanometer. How did you get this one? We know this delta G value. This is equal to surface energy into gamma s plus volume. This is surface area. Sorry, surface area. We can write surface area into, this is surface energy plus volume into delta GB value, change in volume free energy. So this is cube shape. So surface energy will be for cube. Suppose it is length is a. So we can write 6a square gamma s plus volume we already know, a cube delta GB, delta G total. So for critical value we will do delta G by dA. So we'll get 12a gamma s plus 3a square. We will differentiate this term, delta GB equal to 0. So we will get 12 gamma s equal to minus 3a delta GB. So a value will be minus 4 gamma s by delta GB. Minus 4 gamma value is given 0.177. This is joule per meter square. This is minus 2.8 into 10 to the power 8 joule per meter. So if you calculate, you will get nearly what, 2.5 into 10 to the power minus 9 meter. It is asking in nanometer, so 2.5 nanometer. 4 gamma by delta V. 4 gamma by delta V. Yes, you can. There is no need to remember. If you know this formula, then it is easier. Suppose it will be for this spherical shape, then just you write 4 pi r square surface area and 4 by 3 pi r cube, and just you differentiate. It would be much easier. For cylindrical, you can also do. Is it okay? Here we have to find next size. What will be the next size? Tungsten nickel compound. It is prepared by liquid phase sintering at this temperature. If size of tungsten grain is 40 micrometer and the interfacial tungsten and tungsten nickel energies are this one. The predicted average next time we have to calculate. We know melting point of tungsten, it is this one, and melting point of nickel is this one. So nickel is in liquid state and this is in solid state. So suppose this is two tungsten particle, it is compacted, then there will be a formation of neck. This is called neck size. And the surface energy, tungsten to tungsten surface energy means this one, gamma W to W. It is given, we can add solid to solid phase 0.52, 0.52, and this is given 0.3 W and nickel between solid and liquid 0.3, and this diameter is given 40 micrometer. So this is radius, we can say 20 micrometer. So if this is theta value, what will be this value? If this is theta, that means this will be 90 minus theta. So this will be also 90 minus theta. So this one will be theta. Is it okay? And this is right triangle. So from here we know this. Can you find this x? We can write from the energy balance. This direction, total energy in this direction will be equal to energy in this direction. So 0.3 cos theta, this component, plus 0.3 cos theta, this direction, it will be cancelled out because both are the same value, 0.3 sin theta, 0.3 sin theta will be equal to 0.5. So from here what will be the value of theta? 0.6 cos theta, 0.5 cos theta will be equal to 0.5 by 0.6. This is 0.52. So it will be 0.866. So what is the theta value you are getting? 29. Okay, 29. Oh, 29.5. 20.9. So what can you now find out this value? Half neck size. Suppose half neck size is x by 2. We know this 20. This theta value we already know, 29.92. What will be this x by 2 value? What is the any relation, do you know? Sine theta, this value x by 2 here by this value is 20. Sine theta is sine 29.92 degree, x by 2 is 40 we can write. So x value will be 19.95 micrometer. This x is next side total, this one x one. Is it okay? Hello? Okay then. Do you know PV ratio? What is PV ratio? Volume of the metal consumed, you can say. Yes. Volume of oxide formed by volume of metal consumed. So there will be many conditions like if PV ratio is less than 1. I do not have any question right now. But can you tell what will be the condition when PV is less than 1? PP will be greater than 1 and PP will be greater than 1, much more than 1. What? Yes. 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 Hmm. Yes. So it is like bitter type of oxide you will get, right? Tensile stress in oxide film. There will be a tensile stress in oxide film in this condition. And this is just opposite of that. We can say compressive stress. And this is too much compressive stress in oxide film. Means oxide will crack anyway. Do you know Cp minus Cb value? Cp minus Cb we do Nr. Do you know this one? 2021. Okay, I will see. Means next class. What was the question? Beta and alpha. Yes. Okay, Miss. Do you have right now question? Okay, we'll see next semester. Okay, next month. So CB value you can remember this F by 2. This is degree of freedom NR. So if we know this one, for example, for diatomic gases, this F value will be degree of freedom will be 5. For monatomic gases, it will be 3. So from here, if you want to calculate Cp value, you can just write Cb plus R. It will be for diatomic gases 5 by 2 R plus R. So it will be 7 by 2 R. Suppose R value is given, so if they are asking ratio, so 7 by 2 means you can write 3 by 5 R. One second. This is PV equal to N. It is constant, right? So if n is 0 and p is constant, then what will we call? Suppose pv equal to pv to the power n is constant, and in this one n is 0 and p is constant. So what does that mean? What is the system? Is it isothermal, isobaric, or what? Isometric? Can you tell? Yes, this is isobaric. And when n is equal to 1, then yes. And when n is infinite, isometric. And n is what k, then we can say it is isentropic. I think this two is two, isometric means I think this two is only important. This is out of syllabus. This n equal to 1, then pb will be constant, then we can say this isothermal. This temperature is constant. 1 second. Do you know continuity equation q? It is equal to m by flow rate. You can say a1 b1 by equal to a2 b2. This is time, this is density, this is mass. Like if equations are given, you can multiply, put this, and you can find out v1 value or v2 value or even area you can find out from here. So Mach number, do you know what is Mach number? When Mach number is 1, then it is sonic. When it is less than 1, then it is subsonic. When it is greater than 1, it is supersonic. What is Mach number actually? MSCH number. This is like speed of flow by speed of sound. Suppose this is a foreign particle, and the angle is theta. This surface area is beta delta. It is forming this one. This beta phase. This is alpha phase. Suppose it is liquid. This is beta. This is gamma alpha delta. So what will be the this relation? This one, and this one. We can write gamma alpha beta. What will be the relation of delta G heterogeneous and delta G homogeneous? From the energy balance you can calculate gamma alpha delta equal to gamma beta delta plus gamma this one alpha beta cos theta, and here we know delta G heterogeneous equal to 1 by 4 delta G homogeneous, it is 2 minus 3 cos theta plus cos q theta. It is a function of theta value. So when there is a point contact with delta particle, then theta will be 180 degree, and if you put 180 degree, then you will get delta G heterogeneous will be equal to delta G homogeneous. And when beta this phase it completely weights delta particle, then delta theta will be 0, then delta G heterogeneous will be 0. So there will be no barrier in nucleation. And when theta will be 90 degree means this one, then delta G heterogeneous will be, simply you put theta 90 degree, you will get delta half of this homogeneous nucleus. Okay, then do you want me next class? Do you want me to teach like these equations, or do you want me to solve questions?